Okay, so today, as per the syllabus, we're going to be going over conditionals and data structures part one. So we're going to have a number of lectures on data structures. The reason for that is just simply that data structures are a huge part of any programming language. So you want to make sure that we have a good foundation in data structures. So those will so we'll be spending a lot of time on them, which is you know which is a good thing because you're gonna use them constantly throughout your programming career, basically. Cool. So conditionals. So to start out with conditionals, there's a couple different kinds, but they generally all follow the same pattern. There's the if statement. So you'll notice here that there's the if keyword. Whenever you put in any sort of keyword, it's going to show up with at least in PyCharm. If you're using like the dark mode of PyCharm, it'll show up with an orange highlighting. Basically, that means that you can't use that word for anything like variable names or anything like that. It's reserved in Python already. Um, so the if keyword is used as a conditional, and it basically when you put it at the start of your line, that indicates that that line is now a conditional statement. So you have if and then a Boolean or a Boolean expression. So as we mentioned in our data types last week, a Boolean is anything that is either true or false. It's a binary value. It must be true or false. So here, where we do if Boolean, then we have a colon after, and then anything that we want executed in the case that that Boolean is true, we tab that in and place it under the if statement. So here we have if Boolean 1, colon, then we would print that Boolean 1 is true, because the only way that this line of code on line 5 is going to execute is if the value that's assigned to our variable Boolean 1 is true. So basically we want to say, like, if this is true, if whatever statement is here is true, then do what's inside, then do what's tabbed underneath that if statement. So here we're saying if Boolean 1 is true, print that Boolean 1 is true. If Boolean 1 is false, we simply won't execute this line of code. We'll just skip 5 and go straight to 6. Another thing to keep in mind is that we can have a single Boolean value, but we can also have Boolean expressions in there. So remember last week, I think we briefly touched on it, that a Boolean expression is basically anything where you take multiple Booleans and add them together through one of our logical operators, or it can be anything like where we're checking the equality of something using the equality operator, or where we're checking the greater, if something is greater than or less than, or if we're using an identity operator. So any of those logical, identity, or comparative operators or comparison operators can be used in a Boolean expression, and so they're perfectly valid to use here in an if statement. So here I'm checking if Boolean 1 or Boolean 2 are true. Then in that case, we would print out at least one of Boolean 1 and Boolean 2 is true. So here we have our keyword if, a keyword or. The or is our logical operator, saying that if either one of these is true, then this whole Boolean expression will evaluate to true. Only if they're both false will this evaluate to false. So then in this if statement, we're saying that in that case, we want to print out to the console that at least one of Boolean 1 or Boolean 2 is true. So yeah, the only way that this statement on line 8 would not be printed out to the console is if both Boolean 1 and Boolean 2 are false, because then this whole Boolean expression evaluates to false, and then we just skip line 8 and go straight to line 9. And then that it looks like, at least in the screenshot here, that this is the end of the program. So nothing would happen after it. So if Boolean 1 is false, nothing's printed here. If Boolean 1 is false and Boolean 2 are false, then nothing is printed here. But say Boolean 1 is true, then we would print out that Boolean 1 is true here. And then we'd also print out that at least one of Boolean 1 and Boolean 2 is true because of the OR operator being used here. Now, if Boolean 2 was true, then this up here wouldn't be printed out. We wouldn't print that Boolean 1 is true because it's false. So line 5 is skipped. But down here, since Boolean 2 is true, then even though Boolean 1 is false, since we're using our OR operator, the Boolean expression here evaluates to true because of Boolean 2 being true, and we print out that at least one of Boolean 1 and Boolean 2 is true. So now say we had some logic where we want to do some, or say we had a use case where we want to do something in the case that our Boolean expression evaluates to false. So, we have the line of code here where if Boolean 1, then we print that Boolean 1 is true. Otherwise, we put, we would print that Boolean 1 is false. So this else here is basically here. It looks like someone put a marking on the screen. So I'm going to go ahead and stop sharing and reshare. Please don't mark up the screen. I don't know how you do that, but all right, and we're back. Okay, cool. So with the if else, we have our if first. We have a Boolean expression there. And then in the case that that Boolean expression evaluates to false, we do this line of code. So with the if else, say Boolean 1 is true. So if Boolean 1 is true, then this will evaluate to true. So we print out that Boolean 1 is true, and then we do nothing with lines 12 and 13. But if Boolean 1 is false, then what happens here is this evaluates to false. So we don't execute line 11. We go to the else block and we execute that line of code. So else is used as like the catch-all for if the Boolean expression or any of the Boolean expressions that you had above all evaluate to false, then the else is the default that's printed. So in this case, we'll print something, but what that something is depends on the value of Boolean 1. And if there are any questions, please post them to the chat and I will answer them as time permits. Okay, so is it mandatory to skip lines in the program with conditionals? So I guess it depends on what you mean by skip lines. The blank lines that I have here on lines 6 and 9, those are optional. I think it makes it more readable, so I include a blank line. For me, as a programmer, readability is extremely important. I want to make sure that when I come back to my code, I can easily read it and easily understand what's going on. And then my coworkers, I want to make sure that my coworkers can come to my code, easily read it, and easily understand what's going on without having to spend a lot of time trying to decipher any complications there. So personally, I like these blank lines here because I think it makes it more readable. It's like clearly this is its own if statement, and then clearly this is its own if statement. But the skip lines, if you mean skip when like a value is evaluated to false, so in this case, say Boolean 1 was false, yes, that is mandatory that we would skip the execution of line 5. If Boolean 1 is false, we would not execute line 5. There's no way that it could be executed because of how a conditional works. So we would skip to line 6 at that point. There's no code on line 6, so we go to line 7 and evaluate that code. So if you're talking about the blank lines, those aren't mandatory, but encouraged because they make it more readable. But if you're talking about the logic behind, skipping this line of code on line 5 because of the value of Boolean 1 being false, then that is mandatory. That's just how conditionals work. Hope that helps. Cool. Don't see any other questions in the chat, so I'm going to move on. So conditionals continued. So say we had some use case where, if one thing's true, we do that. If another thing's true, we do that. And then we have a catch-all. So that's where the if, elif, else comes in. So here we have the if Boolean 1. So then if Boolean 1 is true, we print out that Boolean 1 is true. And who knows about Boolean 2? Because we haven't checked Boolean 2 yet. So we don't, and we never will, because if this evaluates to true, we skip the rest of the logic in our if, elif, else. We don't evaluate lines 17 or 19 because we know that this one's true, so we just do line 16, and then when that's done executing, we skip down to line 21. This is because only one of the if, elif, or else blocks can evaluate to true, whichever one evaluates to true first. So they all could evaluate to true theoretically, but whichever one evaluates to true first is the one that's actually executed. So we have if Boolean 1, we print Boolean 1 is true. Who knows about Boolean 2? Because we haven't evaluated Boolean 2. But if Boolean 1 is false, then we would come to the elif block and we're going to check the value of Boolean 2. If Boolean 2 is true, then we'll print that Boolean 2 is true. Also, we know that Boolean 1 is false. We know Boolean 1 is false because we made it to line 17. That means that this must have been false, so we evaluated line 17. So we know that Boolean 1 is false. We know something about both Boolean 1 and Boolean 2 at this point. Otherwise, if both Boolean 1 is false, then we skip to line 7 or line 17. Then we evaluate Boolean 2. If that's also false, then we go to line 19. It's our catch-all, so we will execute this. Both Boolean 1 and Boolean 2 are false, is what we would print out to the console there. So yeah, that's how the if, elif, else works. Whichever one evaluates to true first is the one that's going to be executed. None of the others will be executed. And we can chain together as many elifs as we want. So say we wanted to know whether or not Boolean 1 and Boolean 2 are both true, because what happens here is if Boolean 1 is true, we don't evaluate Boolean 2. So Boolean 2 very well could be true. We just haven't checked it. And we won't in the first if, elif, else up here. But if we wanted to check both Boolean 1 and Boolean 2, then we could add another if at the top. And we have if Boolean 1 and Boolean 2, then we would print out that both Boolean 1 and Boolean 2 are true because of the logical and operator that we discussed last week being used here. Else, one of them must be false. So that then we go to the elif block here and we check just Boolean 1. And then in this case, we would understand, like, if this evaluates to true, then we know that Boolean 1 is true and Boolean 2 is false, because the only way that we got to line 24 to evaluate only Boolean 1 on its own is if this Boolean expression evaluated to false. And the only way this could evaluate to false is if either one of these or both of these is false. So if we come in here and then we get to execute line 25 because Boolean 1 is true, then we know that Boolean 1 is true and Boolean 2 is false, because that's how line 22 evaluated to false. And then we have another elif for Boolean 2. So if this evaluates to false, so Boolean 1 and Boolean 2 evaluates to false, then we come to our elif on line 24, check Boolean 1. If Boolean 1 evaluates to false, then we come to line 26, check Boolean 2. If Boolean 2 evaluates to true, then we'll print out Boolean 1 is false and Boolean 2 is true, because we know from the above lines that weren't executed that Boolean 1 must be false and Boolean 2 is true if we end up printing what's on line 27. Otherwise, if both Boolean 1 and Boolean 2 are false, this evaluates to false. Line 24 is checked, evaluates to false. Line 26 is checked, evaluates to false. Line 28 is our catch-all, so we'll print out both Boolean 1 and Boolean 2 are false, because we can tell from the above logic that they both must be false. So it looks like a comment in the chat. I think we will better understand with an example. Yeah, definitely. So I hope the code, I thought, last week it seemed like there was some confusions with having less code examples in the PowerPoints. So I have some real code here. This is valid code that you can reference throughout your assignments. Yeah, I'll definitely show some live examples at the end of the lecture. And if you have any specific use cases in mind, definitely let me know. We can try to go through, these ones here. Cool. I don't see any other questions in the chat, so I'm going to keep moving. So we also have the possibility of a shorthand if. Don't do this. I just want you to know that it's out there in case anyone sees it, because some people might use this. So this is called a shorthand if. It's a one-liner. It's not very readable because you have if Boolean 1 : even PyCharm doesn't like it. You can see it underlined it in gray here, saying that there's some sort of stylistic error with what I have written here. So just don't really do the shorthand. The only reason I'm showing this is because I want you to be aware that it's a possibility and you might see it when you're reading other people's code. So you could do if Boolean 1 and then just print Boolean 1 is true in that case. There's no else here or anything like that. So that's one shorthand. But then there's the shorthand if else. Sometimes this is valuable to use. For now, where you're at the beginning of your programming journey, just don't use it. It's much more readable and easier to understand to do the, to do what's here where we have like all these different sections. But yeah, just know that there is the shorthand if else where you can do print Boolean 1 is true if Boolean 1. So if Boolean 1 evaluates to true, then this line of code is executed. Else we print Boolean 2 is, or Boolean 1 is false. So just know that these shorthands exist because you might see them in other people's code, but don't use them yourselves at this point. It's a lot more complicated than it needs to be. It's something, these are really advanced programming principles with conditionals. So, once you get to a point where you feel comfortable using them, sure, go ahead, but don't try to use them right now. They're not going to be necessary for the assignment or any assignments in this course. They're just something to be aware of as a possibility. But, again, don't use them now. they add more confusion and complexity than is really necessary. Cool. I'm not seeing any more questions in the chat. I'm glad to hear, though, that the examples are useful. On to the next slide. So, so conditionals can also be nested, meaning you can add a conditional within another conditional. Just be mindful of indentation. So in Python, indentation is extremely important. So in other programming languages, there are other symbols that we use to determine what should go, what's like inside of the conditional. But in Python, what we use to determine what's inside a conditional is indentation. So indentation can be either tabs or spaces. Just know that whichever one you pick, be consistent. There's a huge argument in Python programming about tabs versus spaces, and I guess in programming in general, tabs versus spaces. Personally, I prefer tabs. A lot of people, there are definitely some people out there that prefer spaces, but just be consistent. Whenever you pick one, you got to stick with it, because Python will enforce that. If you try to do tabs and then switch to spaces in the middle of your program, Python's not going to be happy about that. So, pick tabs or spaces, stick with it. So if Boolean 1, then we have tabbed underneath that if Boolean 2. So now we're only evaluating line 38 if line 37 is true. So in this case, we come in if Boolean 1, let's say Boolean 1 is true. If Boolean 2, let's say Boolean 2 is false now. So because that's false, we just skip everything that's nested inside of Boolean 2 and go straight to the else, and we print Boolean 1 is true and Boolean 2 is false. But who knows about Boolean 3 and Boolean 4? That's because we haven't evaluated Boolean 3 and Boolean 4 here. But then, just know that you can nest here. I don't want to go through every possible pattern in this, because that can get really complicated, and it would just be time consuming. But just as one more example, say Boolean 1 is true, Boolean 2 is true. Now we're checking Boolean 3 is, let's assume Boolean 3 is false. In that case, then we come to the else block here and we print out Boolean 1 and Boolean 2 are true, but Boolean 3 is false, and who knows about Boolean 4. So something I'd go ahead.
Yeah, David, hi first.
Hi.
When I look at the example, I see if Boolean 1, then Boolean 2 is into Boolean 1, and Boolean 3 is into Boolean 2 with the
Correct.
tabs you put in. Does that mean that? Okay.
Yeah, you're exactly right. So what this means is the only way that the lines of code that are in like line 38 through 44, those will only be evaluated if Boolean 1 is true. If Boolean 1 is false, then we don't even look at lines 38 through 44, and we come straight down to line 45. So yeah, you're totally right. It's basically part of the same if statement there. There's definitely other ways I could have written this using our logical operators of like and or and things like that to get these different things out here. But there's this in Python, there's this thing called PEP8. It's the styling guideline for Python, and it's called the Zen of Python. It's basically one of the things that they say in PEP8 is that explicit is better than implicit. So it can be better to explicitly output things like if Boolean 1, then in here, if Boolean 2, instead of like if Boolean 1 and Boolean 2 and Boolean 3, then print this, and then have a separate like if Boolean, and then have a separate if Boolean 1 and Boolean 2 and not Boolean 3, then print this. So this can be a more readable way to do something like this by nesting your if statements in there. But yeah, you're totally right. These are Boolean 1. The if Boolean 2 is nested within the if Boolean 1, so it'll only be evaluated if Boolean 1 evaluates to true. Yeah, great question. Any other questions? Cool. And I strongly encourage all of you, because we won't have time for me to go through all of these by hand, but I strongly encourage all of you to when you get the slides, take some time to go through and actually try writing this code yourself. You'd have to create variables for Boolean 1 and Boolean 2 and Boolean 3 and Boolean 4 and assign them a Boolean value of true or false. But then you can play around with the values of Boolean 1, Boolean 2, Boolean 3, and Boolean 4 to see how that affects the outputs of your program. This is all valid code that I have here. As long as you write it down letter for letter, it'll work. It's valid syntax and everything like that. Great. All right. So that's it for conditionals. If you have any other questions on conditionals, please add them to the chat. But for now, let's move on to data structures. So a data structure is essentially a means for storing and organizing a collection of data values. So far we've talked about individual data types and variables. Variables are, a way that we can store any type of data. A core data type like a numeric data type or a string data type or a Boolean data type, those are primitive. So data structures are generally composed of primitive data types, such as strings, booleans, numeric data types, but they can include other data structures nested within them. So with the basic primitive boolean or the primitive data types, you can't store another data type necessarily inside of another one. You can't nest them like we saw nesting of the if statements. But with data structures, generally you can nest them. There are some that you can't nest, but generally you can. So each has their own set of methods or a defined action that can be performed on that data structure. Methods are called on a data structure using dot notation. So an example here is if we had a variable that was storing a data structure called data underscore structure. And then we would call using the dot notation here with a period, and then we could call the method on there, and we have the parentheses after. A method is kind of like a function, like we've seen the print function, so you have to include the parentheses after. If you don't include parentheses, it's called a property. We'll get to that a little later on when we get to classes and such, but just know that when you want to call a method on a data structure, you use the dot notation. So you have the data structure's name, so your variable name, dot, the method you want to call on it, and then the parentheses after. And any arguments that are passed to that method, if required, go inside of the parentheses. So there are many different kinds of data structures, each with their own relative benefits and uses. There are sets, tuples, arrays and lists, dictionaries, there are objects, and there are more. You can create custom data structures and all this stuff. But we're just going to go over the ones that are built into Python throughout the next couple weeks. And today we're just going to cover one or two of these data structures just as an initial exposure to it. So we're going to start out with sets. So a set is an unordered collection of unique values that are immutable. So unordered. The elements within a set are not ordered. You can enter them in any order when creating the set, but the order is not maintained. So here I created a set, and the way you create a set is using these squiggly brackets on their own here. So we have like a squiggly bracket, and then my values in a comma separated, basically, in a comma separated structure here, and then another squiggly bracket to close it off. So notice that I enter this in 1, 4, 6, 8, 9, 3, 54, 7, 8. When I hit enter, because the order of that is not maintained in a set, it automatically outputs it into this structure here, where it just ordered it for me. Basically, it put it in ascending order. But just know that in the back end, there's no like logical order to that set. When you create it, it doesn't maintain that set or that order that you had created it in. You can create it in any order you want, but yeah. So unique. All the elements in the set must be unique. Duplicates are not allowed. So here I'm trying to create a set, again, with my squiggly brackets and comma separated values within those squiggly brackets. And I'm putting in 3 1s, 3 2s, 3 3s, and 3 4s. But when I've hit enter there, that's evaluated down to just 1, 2, 3, and 4. So for those of you with a math background, this might make a little bit of sense, right? Because a set in math contains only unique values. So you can't, if you try to add another, if you have a set that has the value 1 in it, and you try to add another 1 to it, it's not going to actually add another 1 to your set because you can only have one in your set. You're only allowed to have unique values. They can't be repeated or anything like that, or duplicated within the set. So trying to create a set with multiples of any number just boils it down to what are the unique values of that comma separated values list of numbers that you passed in when creating the set. So immutable. Immutable means that once it's defined, you cannot change the values of the elements in the set, but you can add and remove elements from the set. So I create a set here. I call it my set. Assign it, and I'm assigning my set the value of the set 1, 2, 3, 4 here. So my set now contains the values 1, 2, 3, and 4. I output it into the console here, and I just get 1, 2, 3, 4 back. So, it's stored there. I just happened to put it in the ascending order here, so that's why it looks like the order was maintained. But remember, order is not maintained. If I had put this in descending order, it would have organized it in ascending order for me anyway. So using my set, I can add the value 5 to it, and this is one of the methods where I'm calling the add method on my set using dot notation. And so I have my set dot add, and then I have my parentheses, and within my parentheses, I want to add the value 5 to my set. So now when I output my set, I have value 1, 2, 3, 4, and 5. And then I can do my set dot remove. So again, remove is another method on the set. Using dot notation, I'm calling remove on my set. So my set dot remove, and then the parentheses, and the value I want to remove from my set is the value 3. So now when I output my set, 3 is no longer in my set. But there's no way for me to, because there's no order to sets, there's no way for me to actually reference the individual values in these sets. I can't say like replace the second value in my set with 4 or something like that. That's not possible because there's no order to sets. So I can't change the values of the set. They're immutable. The values within the set are immutable. They cannot be changed, but they can be added or removed using the methods here. So there are 2 ways that you can define a set. You can do my set equals and then the set the set function. So set and then the parentheses after it. That'll create a set and assign that set to my variable my set. You can also use the squiggly brackets as I've been doing throughout here. So the squiggly brackets, if you just do my set equals these squiggly brackets, then that'll create a set. Be careful with using this second approach. Again, like I was mentioning earlier, Python says it's always explicit is better than implicit. So here I'm being explicit in the first line here, right? I'm saying my set equals a set. I'm specifying this is the function set, so I'm creating a set. But here, where I'm doing the squiggly brackets, I'm being implicit here. I'm saying I want this to be a set. A problem here, and we'll get to this when we get to other data structures later in the course, squiggly brackets are also used for another data structure called a dictionary. So this can be confusing to Python about whether or not, and especially anyone reading your code, about whether or not my set is a dictionary or a set. So it's always better to be explicit and say, like my set equals set. Remember the parentheses after it, because if you just do set without the parentheses, it's going to assign it to the function set. But yeah, so that's how that works here. 2 ways to create a set. This one, the first one is the more Pythonic way to do it, but both will work. Sounded like someone came off mute. Was there a question? All right. Yeah, but please do keep adding questions to the chat. That helps a lot. I think it allows the flow to keep going in the lectures so that I can stop at a natural time for questions instead of mid-slide or something like that. Cool. All right, so set methods. As we saw in the previous slide, we had the add and remove methods. There's also a copy method. So add adds a specific element to a set. Remove removes a specific element from a set. And copy. Copy returns a copy of the set. So here I have my set. I assign it the set 1, 2, 3, and 4. Again, your set is equal to my set is what I'm doing here. So now I'm assigning my set to your set. So now the variable your set contains the same set as my set. So here's where the identity operator that we talked about last week comes in, where I say, where I'm checking your set is my set. Are they the same exact value in Python's memory? They are. It returns true. But now I take my set and I add 5 to it using dot notation. Now I check your set and look, it actually added 5 to it. The reason there is because your set is my set. They are literally the same set in Python's memory. So be careful here when you're trying to assign sets to other, when you're trying to create another value of a set. If I instead wanted to do your set equals my set dot copy, now I'm creating a copy of my set and assigning that to your set. Now when I check, is your set my set? So your set is my set? Yeah, that's false. They are not. They are not the same set in memory, even though they have the same exact values. So this is where the identity operator is beneficial compared to the equality operator, because we want to check whether or not they are actually the same set in memory. Now when I take my set and I remove the value 3 from it using dot notation, with the remove method and passing in 3 as the argument to remove, now my set contains 1, 2, 4, and 5. So no 3 in it is in it anymore, but your set still contains 1, 2, 3, 4, and 5 because they aren't the same set in memory anymore. So making a modification to my set doesn't also modify your set. So just some quick notes on the identity operator there. Yeah, so looks like there's a question in the chat. Is the sets only numbers and letters can be used and not constructed words? Great question. So far I've just been using numbers. You can put words in there. So I could have a set of like letters and words. So I could have full sentences in there if I want. It can hold string values. A set can hold a string data type. Sets can also hold Boolean data types as well. So that they can hold any of our primitive data types that we talked about last week. A set can store that value. Great question. Thanks. Yeah, and keep the questions coming in the chat. This is great. But in the meantime, let's go on to the next slide. So set methods continued. So difference. So set difference returns the elements in one set that are not in another set. So if I take my set 1, 2, 3, and 4, and I call the difference method on this first set using dot notation, and I pass in another set as the argument to the difference method, now the set that I'm passing into the argument there is 3, 4, 5, 6. So now I want to get the difference. What's in this set? So what's in the set on the left side that's not in the set on the right side? Only the values 1 and 2 are in the set on the left side that aren't in the right side because they share the values 3 and 4. So we return just the 1 and 2 that remain from this set. Note how we kind of leave off the 5 and 6. Those don't really matter here when we're doing the set difference because we're taking the difference from the first set, basically remove anything that's in the second set from the first set and then return what remains. So intersection. Intersection returns a set containing the common elements of 2 or more sets. So here we have our first set, 1, 2, 3, 4, calling the intersection method on the first set using dot notation. So set 1, 2, 3, 4 dot intersection, and then I'm passing as my argument to the intersection method the set 3, 4, 5, and 6. Here, since we're checking the intersection with returns a set containing the common elements of 2 or more sets, that'll return 3 and 4 because set A and set B both contain 3 and 4 in them. Those are the common elements there. And something with anyone with a math background here might be recognizing that these methods are actually, mathematical principles on sets. Sets are very important in math. When you in math, you can do set difference, you can do set intersection, you can do the union of 2 sets, you can add and remove elements from sets, things like that. So just keep in mind that this has a strong relation to math. If it helps you to think of it in that way, definitely do, because that's exactly how it works. It's basically using the mathematical principles of sets, just putting it into a data structure that we can use in Python. So then the union method. The union method returns a set containing all of the unique elements present in 1 or more sets. So again, same sets, 1, 2, 3, 4, and then I'm calling the union method on my set 1, 2, 3, 4 using dot notation. So I have 1, 2, 3, 4 dot union, the set 1, 2, 3, 4 dot union, and I'm passing as the argument to my union method 3, 4, 5, and 6. One moment. If you're not talking, can you please go on mute? Thanks. Yeah, and if you had a question at the end of the slide, I'll ask for questions and you can come off mute at that time. All right, so union returns a set containing all of the unique elements present in 1 or more sets. So first set 1, 2, 3, 4. The second set that I'm passing in as the argument to my union method is 3, 4, 5, and 6. This combines the 2 sets and returns those values. Remember, unique values only in sets. So there's not going to be duplicates of 3 and 4, even though both of these sets contain 3 and 4. But we are going to have, the set 1, 2, 3, 4 combined with the set 3, 4, 5, and 6. So now we have 1, 2, 3, 4, 5, and 6. So that's how the union method works. There are many more set methods. These are the only ones that we're going over here. You're not really even going to need to use all these throughout the course or the assignments. I just want you to know that they are there. For your use, should you have a mathematical use case where you want to be working with sets, say you're doing some sort of discrete math or something like that, where sets are used pretty commonly. But if you want to learn more about sets, you can go to this link here and the set methods. Strongly encourage you to do that. There are plenty of methods out there. Maybe the one that we haven't discussed here is more applicable to your use case. So it sounded like maybe someone had a question when they had come off mute. If you want to come off mute now and ask your question, go right ahead. All right. So it looks like there's a question in the chat. So suppose you wanted to write sets of words. Is there a way to continue writing in a new line instead of prolonging the same line in Python? Yes, yeah, you can absolutely do that. It's with sets, when you create these squiggly brackets, even if you hit enter in there and you have like a new line, you can continue to go until you close that set. So you can have it on as many lines as you want. Just make sure you don't close your set until you're done creating the set. Yeah, that's a great question. There's always a way to add new lines into your program, because some of you may have seen when you were doing your assignment that if you type something beyond the like, there's like a gray bar in PyCharm. If you go beyond that character count, it might give you a warning, underline everything in gray, saying the line's too long. It's just a warning. It doesn't mean that your program isn't going to run, but there's always a way to put that down onto a new line, whether you're working with a string or whatever it might be. So I can definitely help with how you would do that if you have any questions on that. Don't worry too much about it right now. You'll see it in examples over time. But yeah, if you want like specific examples on that, I can definitely show you that in due time. But great question. Any other questions? I'm really liking the questions in the chat. This is great. So please, if you have any questions, add them to the chat. Otherwise, if you feel more comfortable asking verbally, just wait till the end of the slide. At the end of each slide, I'll ask about questions. Thanks. All right, so let's go to the next slide. All right, so now we're going to learn about a new operator. The in operator can help us to determine if an element already exists in a set by using it to form a Boolean expression. So here's the example that was being asked before about, can we put words in sets? We certainly can. So I have my set. I'm assigning it the value of the set. Remember, notice my squiggly brackets with my comma separated values in here of David, Matthew, Eric, and Sean. So now I want to know, is David already in my set? So is David in my set? This is a Boolean expression here. David in my set, it returns true because David is in fact in the set already. But if I want to see if Josh is in the set, say this is like a guest list or something. If I want to see if Josh is in my set, I just check Josh in my set. False. He's not. Josh is not in this set. So if this was a guest list, Josh isn't on the guest list. Sorry, come back another time when you are on the guest list, kind of thing, to Josh. So the in operator is super useful for determining if something is already in your set, or if, like say you have a set of values like valid values. Hint here, the assignment is going to require some valid values. So you want to make sure that those values are in the set before you proceed. You would use the in operator there. So a little hint for the assignment there, you're going to be using the in operator and a set of certain values to determine whether or not something entered by the user is actually in the set of accepted values. Cool. Any questions on the in operator? I'm not seeing anything in the chat. All right. I don't see anyone coming off mute, so I'm just gonna head on over to the next slide. Cool. So that's it for the slides this week. Oh, looks like there is a question in the slide or in the chat. David, are we going to use the same arrow prior to those data structures? So those arrows, these arrows here, remember, if you took a picture of the REPL environment, these 3 arrows are just a part of the Python console REPL environment. So that's all that is. When you're executing code in the REPL environment, you'll see the 3 arrows. When you're writing the code in a Python file, you won't see these 3 arrows. Yeah. So should quote marks be utilized with words in a set? Yes, absolutely. Remember last week when we were talking about primitive data types, if you want to have a string, which is, basically letters, or words, or, you can put numbers in a string as well, as some of you may have noticed during the assignment, and gotten some feedback on that we were supposed to be using numeric data types for most of the values in the assignment this past week. Yeah, anytime you create a string, you want to wrap it in quotes. Otherwise, it's not going to be a string. It's going to be interpreted as a variable. And if you don't have a variable, so if I didn't put the quotes around David here, and I didn't already assign a variable somewhere up here or if I didn't create a variable named David, then I'm going to get an error. It's going to be a name error because that David variable doesn't exist. But wrapping it in quotes tells Python, oh, this is a string. This is not a variable here. Because without the quotes, it would think that I'm trying to reference a variable named David. Great question. Yeah, great and awesome question so far. I'm loving all the questions. I hope you're all feeling comfortable enough to ask your questions throughout the lecture. I think it helps me because there are things that I may have missed when I'm going over all this, and it helps your peers because chances are, if you have the question, someone else has the same question. I get a lot of questions that are basically identical from people on the assignments. So ask your questions. Please don't hesitate. I can't read your mind, but I do want to answer your questions. It's what I'm here for. So please ask away. No such thing as a stupid question. So yeah. Any other questions? All right, not seeing anything so far, so just gonna talk about this slide real fast while maybe someone adds any questions to the chat. But some additional resources here. So just like last week, I'm going to be sending out this PowerPoint slide to you all. So you'll have access to these slides, and you can come here and click on the links here. So for conditionals, this link here, it's from W3 Schools again. You can read more about conditionals, see more examples. You can actually execute some of the code examples that they give on W3 Schools, and they give you some exercises at the bottom of the page. I strongly recommend going through all of these resources. Like, we only have an hour together each week for me to talk about all this stuff. There's a ton that I'm not able to cover in the time that we have together here, and maybe I'm not covering it adequately for your learning style. So I strongly recommend going through all of the exercises here and all of the examples. It's extremely valuable. Yeah, I don't have enough good things to say about W3 Schools. They're an excellent resource, especially when you're starting out with programming. So sets, if you want to learn more about sets, strongly recommend you do go to this link here. They'll give you more code examples and explanations on sets and various set methods and all that stuff. And then some exercises on sets, again, on W3 Schools. These are basically interactive exercises that'll give you feedback, instant feedback on whether or not what you're doing there is right or wrong. Cool. So that's it for the slide, for the PowerPoint this week. I'm not seeing any questions in the chat, so I'm just going to move on to the assignment real fast. All right, cool. So for assignment 3 this week, you're going to be building an activity suggestion app. So your client is extremely indecisive with what they want to do in their free time and wants you to develop a simple program to make suggestions as to what they could do based on a few factors. This program should be able to store, hint, when I say store, we're going to store it in variables, a weekday indicator, whether or not it is a weekday. Consider what the data type should be here. This should be a Boolean value. Remember, if it's a weekday, true. If it's not a weekday, false. Yeah, this should be a Boolean value. Just wanted to call that out there. The current weather, this should be a string value. And the funds the user has available to spend, this should be a numeric value. The client lives in a place where the weather is always either nice, raining, or freezing, so the program should verify that the weather entered matches one of these values. Hint: use a set along with the in operators. This is what I was talking about earlier in the PowerPoint. You might create a set with the possible weather types in there, and then use the in operator to make sure what's entered by the user in the weather variable is actually in the set that you've created there. So after verifying that the weather entered is valid, the program should do the following. In the case that it is a weekday, the program should output a reminder stating, you may have work or school today, but here are some suggestions if not. Then, in the case that the weather is nice, the program should output, the weather is nice, so let's do something outside. So everything in this font here, this like TypeScript kind of font, that's what your program should output. The rest is just guidelines on the assignment. So in the case that the weather is nice, the program should output, the weather is nice, so let's do something outside. Then, in the case that the user's available funds are at least 100, the program should output, let's go to an amusement park. Otherwise, the program should output, let's go for a walk in the park. So as I'm going through this, hopefully you're thinking about what kind of thing you're going to use from the lecture today to make this happen. Conditionals. Conditionals are going to be extremely integral to this assignment. So just consider how you'd use those. So now, otherwise, and this otherwise pertains to the in case the weather is nice. So this otherwise, and another hint, the bullet points here are you can kind of look at them as like nesting. So follow along with the nesting of the bullet points to figure out the nesting of your conditionals. So otherwise, in the case that the weather is raining, the program should output, it's raining outside, so let's do something indoors. Then, in the case that the user's available funds are at least 50, the program should output, let's go to a museum. Otherwise, the program should output, let's stay in and watch movies. Otherwise, and then this otherwise is again to up here with checking the then weather is nice, otherwise weather is raining, otherwise, the program should output, it is freezing outside. If you leave the house, make sure to bundle up. Then, in the case that the user's available funds are at least 150, the program should output, let's hit the slopes and go skiing. Otherwise, the program should output, let's stay in and drink hot chocolate while watching movies. And then the otherwise, again, this otherwise, consider how the bullet points are nested within each other. Otherwise, the program should output, it's the weekend, woo, let's decide what to do. Then, in the case that the weather is nice, the program should output, the weather is nice, so let's do something outside. Then in the case that the user's available funds are at least 100, the program should output, let's go to a concert at an outdoor venue. Otherwise, the program should output, let's go on a hike somewhere. Otherwise, in the case the weather is raining, so again, this is in relation to the weather is nice thing up here. Otherwise, in the case the weather is raining, the program should output, it's raining outside, so let's do something indoors. Then in the case that the user's available funds are at least 50, the program should output, let's go to a comedy show somewhere. Otherwise, the program should output, let's go on some free tours of the local places of worship. And then otherwise, the program should output, it is freezing outside. If you leave the house, make sure to bundle up. Then in the case that the user's available funds are at least 150, the program should output, let's check out a local bar and or arcade and play games. Otherwise, the program should output, let's just call some friends and see if they want to come over and play board games. So, you're going to be using conditionals throughout this assignment. Anytime I'm talking about output, remember we use the print function to output anything to the console. There's going to be a number of Boolean expressions in here. Anytime, I'm talking about in the case that, that's probably going to be a Boolean expression there. And then, consider your nesting. You can kind of use the same nesting I'm using with the bullet points here to help in nesting your conditional statements throughout your assignment. Any questions on the assignment before we move on to demos for the day? All right, great. So if there are no questions, let's move on to some demos. So I'm just gonna come over here and let's go to the very beginning of the lecture. So I know there was some mention of seeing the Boolean expressions in an example. So remember, I have to create these variables Boolean1. So as someone had, oh, here's a question. In the case of the assignment, we have the user input some data. So great question. I noticed some of you took my user input thing very literally, which was great. It was interesting to see some of you using user input, the user input function already in your code. That's not required for the assignment. When I say input, I just mean when they change the value of those variables, your program needs to react accordingly. Your program needs to be able to take any values for those variables and handle what those values are accordingly. So yeah, you don't need to necessarily elicit user input using the input function because we haven't talked about that yet. We're going to talk about user input in a later lecture. But if you want to do that, you certainly can. I'm not going to stop you from going above and beyond, but just know that's not a requirement by any means. Just assign your basic variables, and then I can go in and I'll change the values of the variables when I'm evaluating your assignment. Great question. Cool. So back to the examples. Remember, as someone had asked earlier, do the values in the set need to be in quotes? They do, because otherwise it's going to be evaluated as a variable. Since this Boolean 1 is not in quotes, it's going to be evaluated as a variable. So that means I have to create Boolean 1 here, assign it the value of true or something like that. And then I'll also create Boolean 2. Just while I'm at it, let's give that the value false. So now I can do if Boolean 1, then print Boolean 1 is true. So notice here how I have, I have my if, remember your colon at the end of the if, that's really important. And then my print statement is tabbed underneath my if here. And then I print Boolean 1 is true in the case that Boolean 1 is true. If I go ahead and I run this code, it does output Boolean 1 is true. If I change the value of Boolean 1 to false, and then I run this program, nothing's output because this evaluated to false. So line 5 was never run. So let's say, something to keep in mind here, say I had another print here, exiting program. Regardless of the value of Boolean 1 here, it's always going to output exiting program. So, when it's false, it outputs exiting program, because basically what happens when this evaluates to false is it just skips to the next line that's not tabbed underneath the if Boolean 1 there. So it'll always evaluate line 6 since this isn't under a conditional or anything. So even if I change this to true, run that, Boolean 1 is true, and then it says exiting program. Cool. Let's just keep at it. Let's leave that at the bottom, and then I'll put in this next conditional here. So if Boolean 1, print Boolean 1, Boolean 1 is true, else print Boolean 1 is false. So let's just remove this code here for now. So if Boolean 1 is true, so right now Boolean 1 is assigned the value true, so we get Boolean 1 is true, then exiting program. If I change Boolean 1 to false, then I run this code. Then it says Boolean 1 is false because this evaluated false. We don't run line 5, but we do skip to the else because this is our catch-all. If everything above evaluates to false, then we come to the else and it prints Boolean 1 is false. Cool. And then again, exiting program, it's being printed out every single time because it's not nested under any of the blocks in the if else. Let's check out this one here. So take out this code and then we'll write this code here. So if Boolean 1 print Boolean 1 is true, who knows about Boolean 2 though? And then elif Boolean 2. Boolean 2 is true. Also, we know that Boolean 1 is false. And then else print both Boolean 1 and Boolean 2 are false. And note that all these things have to be in quotes here because they're strings. If I don't include these quotes, then it's gonna again look for variables. So if I do this here, it's looking for a variable named both, a variable named Boolean. It's using the logical and operator, looking for variable Boolean 2, looking for variable R, and then the false data type, and then the exclamation point can be considered a not in many cases. So just keep in mind, quotes are very important when you're working with strings. So always include your quotes. All right. So right now, both values are false. If I go ahead and run this, then we get both Boolean 1 and Boolean 2 are false. Great. That's what we expected. If I change Boolean 1 to true, and that's because, this evaluated false, check line 6, also evaluated false. Come to line 8, it's our catch-all, so we execute line 9, both Boolean 1 and Boolean 2 are false. This is only executed because both of the above evaluated to false. But now, if I change Boolean 1 to true and run that, we just get Boolean 1 is true. Who knows about Boolean 2, though? So all we evaluated was line 4 here. Since this was true, we output what's nested underneath that block of the conditional, and then we don't even look at the rest of this. So it doesn't matter that Boolean 6 is false. We have no clue about Boolean 6 or Boolean 6, Boolean 2 on line 6. We don't care that it's false. Even if I change that to true here, we're going to get the same exact behavior. If I run this again, we get the same exact output. It does not matter that Boolean 2 is true. It doesn't affect the impact of this particular program because we're just checking, because we only evaluate whichever one is the first one to evaluate to true. Only that line of code is executed. We don't care about the rest. We ignore the rest. But if we make Boolean 1 false, then this will evaluate this one. That'll evaluate to false. Because that evaluates to false, then we come to line 6 and evaluate line 6. That'll evaluate to true. So we'll see this output here. So let's run that. So we see Boolean 2 is true. Also, we know that Boolean 1 is false. The reason we know that Boolean 1 is false is because the only way we evaluated line 6 and whether or not Boolean 2 is true is because Boolean 1 evaluated to false. So we went and evaluated line 6. So I know this might seem a little complicated, but it's very worth just taking the time to go through and try all this on your own. Something to note on this particular slide, there's an animation here. There's actually some stuff under like something that's hiding it here. So it might help just to, present and then click here and it'll show you the if, elif, else all on here. Just wanted to call that out for anyone who is trying to go through the slides and do everything that I presented here. I'm not going to show the shorthand if, and I'm going to leave this one for you to practice on your own since we're basically at the end of the lecture time anyway. But yeah, nesting is going to be required for your assignment. The set stuff, there are lots of code examples in here. And just to that question about the 3 arrows, remember if you come down to the Python console down here at the bottom left of PyCharm, that's where you'll see these 3 arrows here. So that's where I was taking the screenshots when I was doing all this stuff here. You can tell it's a REPL environment because all I did was create a set here, hit enter, and then it evaluated that stuff there. So a question in the chat, can one replace the word Boolean with something else instead? Absolutely, great question. Yeah, so I don't have anything in here about like what these variables mean. If these variables had some sort of meaning beyond just being a variable to store a Boolean value, I would have given them a more informative name, like you should do in your assignments. So let's just say like I wanted to change this to I don't know what name. Let's just call it something else. So now that I've replaced that variable name, and another note that I saw come up in some of the assignments, whenever you create a variable, don't include spaces. If I include spaces here, it causes issues. It's underlined in red. It's calling out that I have a bunch of issues here. If you want spaces in your variable names, use underscores to replace those spaces. But anyway, so since I replaced the variable name Boolean 1 with something else, so now my variable name is something else. This is underlined in red because unresolved reference to Boolean 1. There's no variable named Boolean 1. So I just have to come in here and change this to something else. And the code's going to work exactly the same way as it did previously. So the name of the variable doesn't really matter. The name of variables is more so for the person writing the code and for other people who are reading that code. You want to make sure that your variable names are informative and useful to what the variable is holding. So, in your assignment, it might make sense to have a variable named like weather or a variable named weekday, things like that. Another question in the chat, can we start the variable with capital letters? You can, but it's not recommended. The reason for that is that it's not Pythonic as they call it, but I certainly could. I could, call this something else here. And then I would just have to replace something else down here. Variables are case sensitive, so that's a good thing to call out there. Variables are case sensitive, so if you do start it with a capital letter, make sure you're starting it with a capital letter throughout your code there. But generally, you don't want to use capital letters in variable names. The part of the reason for that is it gets complicated with making sure that you're keeping your capital letters consistent throughout your code. If everything's lowercase, then you don't have to think about which letters in my variable were capitalized, because I could even capitalize a letter in the middle of my variable name if I want. But again, it's like from a readability, usability, maintainability perspective, it's not good to include the capital letters in there. So while you certainly can, it's not going to be counted against you. I'm not going to grade based on that or anything like that. I would recommend you don't use capital letters. It's just easier to just keep in your head everything's lowercase. Also, generally with capitalized variables, if you're going to capitalize a variable, generally you would that's going to be a constant. So something that shouldn't change. That's a convention in Python. It's not necessarily enforced, but it's in Python, there's the convention that anything in all capital letters, you shouldn't reassign that variable. So say I had like a variable called like speed of sound. The speed of sound never changes. I can't think of what it is off the top of my head, so I'm just going to put in a random number here. But the speed of sound doesn't change, so I would put it in all caps, specifying like, don't change this variable, it's a constant. So yeah. Another thing to be aware of, you might see this, people might sometimes name their variables using camel case instead of snake case underscores here. This is a snake case. Camel case is where you do something like this, something else. So you instead of having underscores, you do your next words are capitalized. Python, best practice in Python is to use snake case, but many other programming languages like Java, for example, they use camel case in a lot of cases. I prefer snake case. I'm not going to count it against you if you want to use camel case, but I prefer snake case personally with the underscores in place of the spaces. But just know that you might see that. You might see camel case in other people's code throughout your programming career. You won't see it from me because I prefer snake case. So awesome questions. Are there any others before we call it for the day? All right. So I'll take silence as no other questions. If you do have more questions after the fact, I know sometimes it takes time to think of the questions. Please, if you feel comfortable, post them as a comment on the YouTube video. I'll try to be better about checking the questions posted there. And then it always helps other people. It always helps other people because other people might have the same question as you. They can go to the video. Maybe they feel a little more shy about asking me a question. If you ask the question on the YouTube video, they had that same question. They go check the comments on the YouTube video. They don't have to ask the question, and I also don't have to answer the question twice. So that's always a great way to do that. Another question in the chat: snake case versus camel case. What is the difference? So difference is really just this is snake case equals, notice the underscores in place of spaces. So that's snake case, and then this, not this, with a search. So this is camel case. Notice the capitalization of subsequent words. This is really the only difference. It's underscores versus capitalizing underscores between words versus capitalizing later words to show separation. There's no difference to Python itself. There's no difference to the engine that's interpreting your code. It's just a convention. Personally, and I think this is why Python chose snake case as the convention. I think it's a lot more readable because it's easier for your brain to substitute in underscores instead of spaces. Camel case, it takes some getting used to when you're reading it, because you have to recognize, oh, there's another capital letter, that's a different word. Oh, another capital letter, that's a different word. Instead of just obviously the underscore being replaced with spaces, your brain can easily make that substitution. This one takes a little more practice. But this is the difference between the two. Not really, no difference to the program itself. Mostly a difference to the people reading your code. And I think snake case is easier to read than camel case. Great question. Cool. So I'm not seeing another question in the chat, so let's go ahead and call it for today. I know we're a little over. If you have any more questions, please do ask them on the YouTube video. You can also feel free to email questions to me, but if you feel comfortable, please do ask on the YouTube video. So thank you all so much for joining today. I will send out the PowerPoint slides and assignment here right after we're done here. I will also start uploading the video to YouTube, and once that's uploaded to YouTube, I will also send the link to the video of the lecture. Yeah, so thank you all again for joining. I hope you all have a great rest of your weekend, and I will talk to you all next week.